I'm Salman Khalilulahi, and this is the Team 6 forum presentation. Other members of this team are Michael Royer and Brendan Seibert. The topics we'll discuss are CI/CD with Azure DevOps, which I'll talk about. Michael Royer will then discuss working with Mapbox. And lastly, Brendan Seibert will talk about working with Google BigQuery. So first I'll discuss CI/CD with Azure DevOps. The CI part of CI/CD is continuous integration. This includes frequently committing to the source code repository and merging branches within the repository. It also includes consistent and automated methods for building, testing, and packaging software. This is the part that can be implemented using Azure DevOps pipeline feature. The rationale for using this type of strategy is that committing changes more frequently improves team collaboration by allowing team members to see each other's changes more quickly. Also, consistently run automated tests improve the quality of code released by allowing problems to be identified earlier in software development. So how would we go about implementing automatic testing in Azure DevOps? Well, the steps for automated testing procedures are defined in pipelines, which in turn are defined by YAML files placed in the source code repository. In this example, we have pipeline code that runs tests with coverage, which I'll talk about in more detail later. This example code starts by declaring that it will be triggered for all branches of the repository. That is, it'll run anytime a commit is made to any branch. The next section declares that it runs on Microsoft's temporary Ubuntu virtual machines, and that 3 jobs will be run with 3 different versions of Python. The next section here downloads a secure file, which is an example of what's called a secret. That is, any piece of information or file that is not public and should not be kept with the source code, that is, passwords or API keys. Next, we have the section that runs the tests themselves. And lastly, we publish the results once the tests have finished in order to view them in DevOps report pages, such as this one. This shows test results for a sample run containing basic information like the commit that was tested, the overall results of the test, and the code coverage of the test, which again I'll discuss in more detail later. This page also contains warnings that were generated during testing and a breakdown of the jobs that were executed during testing. So now we'll discuss code coverage, which is the proportion of source code instructions that get executed by the software tests, which is a metric that helps to measure how thorough the tests are. It's not the only factor to consider, but it's a helpful measurement. Here we see the overall a summary view containing overall coverage for the entire code base. And here we see a report that breaks it down by file. And this type of report helps in visualizing where more effort needs to be allocated with regard to tests. Next, we have the continuous deployment, or CD, part of CI/CD, and this continues where CI left off by automatically deploying the application. This might be set to automatically deploy a branch of the repository, for instance the main branch or a dedicated release branch, or it might be set to deploy on a schedule. The rationale for using this type of strategy is that it allows more frequent releases, which in turn allows more effective and responsive iterative improvement by agile teams, by allowing stakeholders to give input more frequently. So how do we implement this in DevOps? Well, we start by creating an environment in the DevOps interface, and then install the Azure Pipeline Agent on the target server that we intend to deploy to. This registers the server with DevOps and allows DevOps jobs to be executed on the server directly. Then we have to write a pipeline that performs the deployment, an example of which is shown here. This pipeline specifies the environment that it will run on. Note that that's the same name that we declared to DevOps here. And then a series of steps to actually carry out the deployment. The first main piece is to check out the source code repository. This is something that might need to be done depending on your build process. It's an optional piece. The next part of this example performs the deployment itself via a Python script that builds, stages, and deploys the application. Next, Michael Royer will discuss Mapbox.
Hi, my name's Michael Royer, and I'm going to show you all about Mapbox, which is an API platform that we've made use of for our senior project. Mapbox is a mapping and location cloud platform for developers. They call themselves the building blocks, the SDKs and APIs for developers and designers to build real-time location awareness into their own apps. They actually have a ton of features and APIs that our group will probably never tap into for our purposes. Things like routing engines, search and geocoding, vision, which is it's essentially a powerful AI Street View navigation software, and much more. Various APIs and SDKs that Mapbox develops are used a lot by companies as a cheaper alternative to Google Maps, since Google Maps raised the price per 1,000 loads. I would even say, based on what I've learned so far using it, that Mapbox is at least as versatile, if not more, than Google Maps. Mapbox maps are more customizable, their SDKs are open source, and they provide much more flexibility when it comes to offline mode, thanks to their use of vector maps. The only downside to Mapbox is its availability of up-to-date data. Because of the disparity in use between the two companies, there's a few areas on Earth, such as India and Israel, where Mapbox simply can't match the coverage of Google Maps. But I digress. For our purposes, we are making use of Mapbox GLJS, which is a client-side library designed for web apps that need highly interactive maps. It's a JavaScript library that's able to render maps dynamically by combining vector tiles with style rules. So traditionally, JavaScript map libraries have two distinct categories called layers and overlays. Layers are basically image tiles that form the foundation of the map, where overlays are often vector data in the form of a GeoJSON or some other shapefile that maps out coordinates of geographical elements. Mapbox GLJS is a little bit different. It does also use GeoJSON and other similar file types to define layers, but it actually has no distinction between base layers and overlay layers. So actually all layers can be manipulated using JavaScript. So what makes Mapbox maps so customizable? It's actually the ability to create custom styles using their online tool called Mapbox Studio, which is just a browser application that allows users to create custom styles, tile sets, or data sets. So I'm going to do a little demo to show you how to use Mapbox Studio and how to add a custom map to your own web application. So this is Mapbox Studio. In Mapbox Studio, you can create or edit existing styles, tile sets, or data sets. So for this demo, I'm going to be creating a new style and showing you what we can do. So you can select from basically templates that they create of various styles and themes containing different information. So why don't we just work off of a monochrome, and we'll just leave it how it is. By the way, pardon me if some of these things don't render properly. There's little windows that sometimes don't show up in the screen cap software I'm using. Anyway, so once your map loads, you'll see in this left side panel that elements on the map are separated into components and layers. Now all of these layers on the layers panel belong to one of these components in the component panel. So for instance, administrative boundaries represents all of the, they don't have intuitive names here, but it represents all of the country borders, territories, states, basically all of the borders on the map. And then you have buildings, land, water, and sky, which is essentially all of the fill areas and the foundation of the map. Natural features, place labels, points of interest, which I think you need to add. Road networks, which hopefully you'll be able to see when I zoom in. They'll show up. And transit, which is similar to road networks. One of the main things you can change is colors. And if we go to manage colors, you can change the base colors, which uses a set of presets to change all of the colors used on the map to specific shades of whatever color you choose. But as a demonstration, I'm just going to try to change the colors of our administrative boundaries. So if you want to change the color of something specific, you have to basically activate the colors for that component. So if we want to affect administrative boundaries, we'd have to activate it and then change the color to something like a dark red. That would show up. There we go. So one of the things that we were trying to figure out early on is how can we affect in this map something specific, for instance the entire United States, without affecting the rest of the world, because as you can see, when I changed the color of those administrative boundaries, they affected all of the boundaries across the map. What you have to do essentially is upload a GeoJSON file or some other shape file that specifies coordinates for the shapes of specific entities, and you can easily find GeoJSON files for just the United States, and they can contain any amount of and any different data points that you can actually manipulate and use. So I'm gonna do a little demo of how to create what's called a choropleth map, which you've probably seen somewhere like cell phone provider commercials where they show their coverage across the United States and basically applies color gradients based on the density of that data. So what we can do is we can leave that border the way they are, and we can add a new layer using a source that I have prepared for state data. And once we select that, it shows us using what they call X-ray view what areas of the map that's going to affect. And this is just going to affect the United States and its territories. So what we can do to create this choropleth map based on the population density that's contained in this GeoJSON is we can come back to style now that we've added this layer and select this option, style across data range. And what this is going to do is it's going to use these properties that it detects within that file for all of the objects in the JSON. We can use density to define what color all of the states are going to be. So the way we do that is we add stops, and it automatically creates 2 stops, and that will be enough for us to create a gradient based on population densities. So this is a very basic choropleth map that shows population density based on darkness of color. So if you wanted to add this to a web application, all you have to do is first publish it, and once it's published, you go back to your styles, find it in the list published a few seconds ago, and you can come to this little menu over here and copy the style URL that they give you. And what Mapbox does is they give their users basically a boilerplate code that you can inject into your HTML files as JavaScript. And all you have to do in that boilerplate code is replace their style URL with your style URL, and it will automatically update the map as it appears on the site. And I'll show you that in just a second. So here we are. This is basically a Python Django application I whipped up for this example. So all you need to do to put in your custom style is to come to this style attribute and replace their link with your new link, which their link was actually a link I had there before. So now we can come to our local host server, and there's our map that we just created. So the nice thing is whenever you want to change this, all you have to do is go to Mapbox Studio and edit the style, and whenever you publish it, the next time you make an API call, it will be the updated style because it uses the same URL. So that does it for the demo. Now we're going to move on to Brendan, and he's going to talk about BigQuery.
Hello, my name is Brendan Seibert, and I'll be presenting on Google BigQuery. What is Google BigQuery? They describe themselves as a data warehouse. It's a place where you can create and delete data sets and tables. You can query those data sets like they're SQL databases. You can share your data sets with other people or with the public. You can access free public data sets, and it has some machine learning capabilities utilizing SQL. But my team didn't really explore those possibilities, so I won't go into machine learning today. How to access data. There's 3 main methods to access data through. There is the Cloud Console, which contains, well, I'll begin with, it's an online resource, it's a website. It contains a navigation menu, which displays your data sets and what data sets you're looking at. There is the Explorer panel, which you can view public data sets and search for data sets in. And there's a details panel that displays data on each data set that you're looking at or what table you're looking at, so on and so forth. There is the BQ command line tool, and that is a Python-based command line tool. And the third way to interact with the data is making calls to the BigQuery API via Java, .NET, or Python. Python is bolded because my team utilized Python. The public data sets. So there's tons of free public data sets that contain a lot of information that you can just access immediately. On the right, there's an image of the Explore panel where you can search through the list of free public data sets. I wanted to talk today a bit about specifically the COVID-19 public data sets. If you're looking to see any very specific information on COVID-19, this is the place to go. They were made publicly available in March of 2020 with the intention of increasing access to critical data. It's free, anyone can access it, and it's going to be available through September of 2021. So if you want to do any interesting things with it, do it before September. Making calls to the BigQuery API via Python. This has to start in the BigQuery Cloud Console online. where you have to enable the BigQuery API for a project, set up authentication by creating a service account key page, selecting the role of owner, and generating a JSON that contains the key downloads for your computer. You then have to set the environment variable for your project to the path of this downloaded JSON, install the client libraries, import the libraries, initialize a client, and then you can write and run queries from Python. So this is just an example of a query. It's just essentially a SQL query written out. Pricing. I'll start with what costs money and then get to what everybody wants to talk about, what's free. So there are storage costs and query costs. Both come in two different varieties. So for storage costs, there is active and long-term. Active describes monthly charges for data that you've stored or modified within the last 90 days. And that scales based on how much you store or change, obviously. And then there is long-term data. So that refers to lower monthly charges that are based on data that has not changed within the last 90 days. On to querying costs, there are two types again. There's on demand, where the price is based on how much data is processed by your query. And then there's flat rate, which you purchase a flat dedicated resources to use for the querying process, and then when you're out of them, you're out of them. Price and continue, onto the free stuff. You get storage of up to 10 gigabytes free per month, and as far as queries go, you get the first terabyte free per month. Overall rating, I recommend it. It has very fast querying that we experienced. It's free for the small scale, so for the project that we're working on for our senior project, it's completely free, and it's a very valuable tool, and they promote digital humanist ideals like making sure that people have free information, and I like that. That was our presentation. Thank you for your time. Thank you for listening. Have a good day.